Hi everyone, welcome to this channel of physics. This question has been taken from Irodov electrodynamics question number 16. The question says a sphere of radius r carries a surface charge density of sigma is equal to ar, where a is a constant vector and r is the radius vector of a point of the sphere relative to its center. Find the electric field strength vector at the center of the sphere. So let us solve this question. In the question, it is given the radius of the sphere as r. The charge distribution on the surface is complying this equation a dot r, where a is a constant vector, means its magnitude and direction is same throughout, and r is the radius vector of the point lying on the surface of the sphere. So we are considering a point a theta distance away from the vector A direction. Okay, and what we have to find is the electric field strength as well as its direction at the center O, because of the charge distribution on this sphere that is complying this equation, that is following this equation. So if we take this small thin ring section at this point, theta angle away from the vector A, so what will happen on this thin ring? The charge will be uniformly distributed because theta is not changing for this thin ring. This is the side view. For your convenience, I have made it here. Thickness of this ring is very small, infinitesimally small. That is given by the r d theta. This is d theta angle. Now if we go and focus on this equation, so a dot r will be ar cos theta. So when theta is equal to 0, the charge density will be maximum, because a is constant, r is constant, and cos 0 will be 1. Same way, when the theta is pi, the magnitude of the charge will be maximum because cos theta will be minus 1. A is constant, r is constant. Minus sign signifies that it is having a negative charge on this side. For theta is equal to pi by 2, what will happen? Cos theta will be 0. So charge density will be 0. So there is no charge at pi by 2. So overall with this equation, what we can understand that from theta is equal to 0, where the charge density is maximum in magnitude, and when we gradually increase the theta from 0 to pi by 2, the charge density will keep on reducing because cos theta is reducing. And at pi by 2, it will become 0. Moment it crosses pi by 2, the cos theta sign changes and negative charge will start appearing here. The same thing will happen here. It will be minimum. Here it is minimum, and gradually it is going down. Negative charge magnitude maximum over here. So this I have given in the write-up. You can go through. You can easily understand. This ring I have drawn to understand that this is the end view of this thin ring section. This portion has been shown in last for better understanding. So now if we have to calculate the charge on this thin ring, so what will you do? That charge, if we say that it is dq charge for this dA area ring, so how will you calculate the dA of this ring, the area of this ring? So you need to know the radius of this ring. So radius you can easily find from here, from right angle triangle. This is r sine theta. So r sine theta is the radius. So 2 pi r sine theta is its perimeter. And if we multiply with the width of it, you will get the area. So this is the equation. So from here you will get dq as 2 pi r cube a cos theta sine theta d theta. And this we have named as number 1 equation. Now from symmetry of the charge distribution, it can easily be understood that the electric field will be in the negative direction of the vector A, as that happened in case of a uniformly charged thin ring. If you remember, in thin ring with a positive charge on it at a x distance away from the center, the electric field is always along that x direction. For understanding, for understanding, I have given this diagram over here so you can evaluate that. Okay, this section is having, if we take the charge here and see the E field because of this at center O, so E field will be in this direction, electric field will be in this direction. Just opposite it, the same quantity of charge will also be having E field in this direction of the same magnitude. If we take the vertical component, means in this direction, both the component will be same but opposite in direction. So this will cancel out. So what is happening? Component of this and component of this field will add up and give the electric field strength dE, like this. So electric field at O, that is origin, due to charge dq on thin ring from the formula as had been learnt earlier in the electrostatics. The E field because of ring, it can be expressed with this equation: dE is equal to dq by 4 epsilon naught r cos theta r square sin square theta plus r square cos square theta to the power 3 by 2. For the direction, since it is in the opposite direction of A vector, so we have to take a cap, means unit vector in that direction. To make the unit vector in that direction, A has been taken with negative sign and it has been divided by the same magnitude of A. So this is the unit vector in the negative direction of A. So we have reached to this expression after putting the value of dq from 1. Now the field direction for all the sections of the sphere will be towards the negative side of the vector A. Thus integrating both sides and considering the range of theta from 0 to pi will cover the entire sphere and the resultant E field will be obtained. Hope you understood this. Nothing special in this. You have taken one section of the ring, another section of the ring will be here, another section of the ring will be here, another section of the ring will be here. Same way it will be on the other side. So if we calculate the theta from 0 to pi, the entire ring will sum up and will give a shape of the sphere. So upon integrating for the theta value 0 to pi, we will be getting the E field like this. You can integrate, put the value of theta as 0 to pi. Finally, you will reach to this solution. So this is a simple integration. So you can do it easily. So hope you understood how this problem has been solved. In case of any doubt, please do let me know in comment. I will explain. Thank you.